So from Italy, from Enschede?
From Italy.
Italy? Margherita, good morning. And Dario, you are from also Italy?
Yeah, from the University of Turin.
Nice. And Joop, you are not far from me, I imagine.
No, in the Netherlands, in Heerlen.
Heerlen, yeah.
Yes.
So I'm broadcasting from Amsterdam, so we are all
Amsterdam,
connected.
yes. Your office, yes.
Michiel.
South
I'm
of Limburg, I
broadcasting from
guess.
Maastricht now.
Okay.
Maastricht.
Good morning.
I'm at home.
So I think we can start to introduce, and maybe some audience can join ongoing, just because we have a very strict time, I think.
Yeah.
So, okay, good morning to everyone, and welcome to this track on circular building design method and assessment. And I will introduce very shortly the track and some technical stuff. Okay, I have not to just to introduce to say how important is this conference and especially this track because of the huge impact of the construction material on the environment. I think everyone knows that more or less the construction material consists of more at least the 50% of global material extraction, and they are responsible as well of the majority of the waste in the world. And by the way, how we can face this problem? The circularity, of course, is one of these answers, and I think the way is the circular economy give us some tips and some suggestions to follow in order to first to reduce the use of material and design like in the circular principle, design out of waste our society, and to create, especially in the built environment, regenerative design for the building. I want just to introduce a very quick concept in order to introduce all the talks, because I would like to remember to everyone that in reality we are speaking about material. In circularity, the focus is on the material, but the real problem of in the planet is not on the material itself. It's like a false myth generally that we are saying, everyone is saying that we are like running out of material, that it's not completely true. Of course, in 1,000 years we cannot continue to extract, but we are not running out of material right now, especially for the built environment, because generally a lot of the material used are very common on the earth. But the main point, the main problem, the issues that we have to face is twofold. One is about geopolitical risk in some cases for some very rare material, because maybe the extraction derived from a single country or a few countries that produce the majority of that material in the world. And second is not, again, a problem related to the material itself, but to the, I can say, the footprint, the embodied impact that the extraction, the production, the use, and at the end, the dispose of the material create to the environment. So it's fundamental to think, in any case, about the footprint I can say like about the embodied energy or carbon or other impact category that the life cycle of a material produce. Okay, this just to give a very quick introduction on this track. So how we can face about these issues? I think one, of course, is related, like the name of the track give us a suggestion, is about is working on the design of product of the building itself, in order to improve the circularity, to improve the recovering of the component itself, or to recycle the material. So just closing, we have five different talks, and each talk will present a different aspect regarding the circularity and circular design in the built environment. The first talk is properly from the Parsad region that is virtually hosting right now this conference. And from a very interesting pilot project. The second one will be from the second talk will be from Italy about a green public procurement pilot project. And then we will have a talk about a comparison regarding policy and circularity project in different European countries. And a fourth and fifth, the fifth talk regard more the business model and the impact on the price of the houses if we include like multifunctional building and in the price policies. Just to conclude, I remember to all speakers. Okay, we test with someone of you that you have to share your screen and put in full screen mode before to start to speak. Each talk must last 10 minutes at maximum, and at the end of all the talk, there will be a question and answer session of 20-25 minutes. So I give the word to Joop.
Yeah, so
The first talk.
Yes, so let's hit the road very quickly because we already took about 6 minutes for the introduction, but we will manage. The first presenter will be Michiel Ritzen. Michiel is a researcher connected to Smart Urban Redesign Research Center, and his presentation will be about the reuse of materials. Stage is yours, Michiel.
Yes, thank you, Joop and Dario, and thank you, Dario, for already paving the road a little bit. What it's all about. It's not only about the materials, but it's about the effects of materials. And let me share my presentation here. If I'm not mistaken, everyone sees it now correctly.
Yes.
I see some people nodding, so that's excellent. So we looked at the environmental impact of, I see actually, this is the wrong presentation. Wait a second. I will.
Well, I do see some waste, so it could be the start of your story.
No, that's not the correct one. Wait, maybe we can switch to the next speaker. I will have to upload my other presentation. I'm sorry for the inconvenience. I see I mixed up my two presentations.
Okay. So then Dario, will you please introduce our second presenter?
Okay, the second one is from Margherita Finamore, and will present a talk titled Green Public Procurement, Learning from Pesaro City, Italy. Margherita?
Okay, thank you. Thank you, Dario. Thank you for your introduction and welcome to everybody. Many thanks for inviting me at this conference. And also let me thank Professor Assche from RMIT of Melbourne that she gave me the opportunity to develop this work together. I hope you will. I don't see my presentation. You will see my presentation.
No, it's gone. It was there in the beginning, in the very beginning, but now it's gone. So you have to share. Yeah, there it is.
Yeah. Okay.
Yes, it's back.
Okay. You can see?
Yes, please.
Okay. So I'll be speaking to you about the green public procurement and the lesson learned from its application in Pesaro, my city, Italy. And okay, and let's start from the context and why the building sector is so important now, and which is the situation in Europe, and then the relationship between the circularity and the procurement, and a focus on green public procurement in Italy. And finally, the description of our case study and its findings. So let me give you only some numbers. The building sector alone accounts for 36% of the total amount of energy used, and the consequence is that the building sector is responsible for 39% of the total global emissions. So in Europe, the final energy used in the building sector is about 35%, and based on the report of a Copenhagen Research Institute, the chart on the right, you can see on the right, the yellow one, the building sector the distribution of the raw materials consumption measured in terms of million tons in the EU country. You can see Italy is only after Spain, Germany, and France with about more than 550 million tons. Furthermore, rising living standards and population growth will push the use of raw materials to unprecedented levels in the coming decades. According to the projections of the OECD report published just on February 2019, the use of sand, gravel, and rock will nearly double by 2060. Over half of all current greenhouse gas emissions are related to materials management activities. And in Italy, the 45.5% of the total waste production in comparison to the other sectors belong to the construction sector. So let's dig right in the construction waste materials production. According to our study, the demolition, the construction mixed waste accounts in Italy for 40% of the total waste production. And all these numbers show how it is important to change the approach towards the waste management and the importance of the building sector. In our case study, we have not simply applied the waste reduction or maximized recycling, but in the application of the principles of the circular economy, the waste management has been developed to trigger a process of control and monitoring of all materials and waste during the construction phase. Our research showed to change the traditional approach in the green public procurement to obtain significant results. It means adopting a more circular approach based on thoroughly analysis and environmental claims to obtain not only energy efficiency, but circular buildings with a low environmental impact. And in Italy, this is the symbol of the green public procurement in Italy of the Ministry of Environment. You can see in the picture. And since 2017, in Italy, it is mandatory the law called the Minimum Environmental Criteria that identifies the environmental criteria at a national level according to the EU common targets. But the application of this law especially concerning works, is not so frequent. Only about 19.3% of Italian municipalities have just already adopted. And sorry, okay, this is our case study. This case study I would like to present starts from the ambition of the city of Pesaro City to accelerate a transition toward a circular economy, enabling construction firms to use a new system beyond the current outdated take, make and dispose model contribute to mainstreaming the circular economy concept within and outside the city. The intent is to optimize circularity and enhance the use of sustainable building materials and technologies, save raw materials, and minimize waste from the construction of the building. Instead of taking a traditional approach to developing works procurement based on the lowest price, the city decided to adopt a more circular approach within the tendering process to build a sustainable new school using the current asset. So the aim of this project is to go beyond the resource efficient use and cleaner production since the design phase, during the construction phase, and based on the tendering process. What's more important is that the call for tender describes a clear technical specification and provides measurable requirements against which the tenders can be evaluated. Performance-based criteria describe the expected results, which outputs are mandatory. In the case of this project, the two main criteria were selected as mandatory. Firstly, obtaining a near zero energy building school, and secondly, providing the environmental energy certification using the LEED scheme certification, achieving at the minimum the LEED gold certification. This is the first Italian project that approached the GPP with a clear, ambitious request of environmental criteria. As regard the waste materials, the strategies was developed by controlling all incoming and outgoing materials from the construction site. The importance of the green public procurement was to make mandatory the obligation to deliver all materials from demolition to recycling center, and also provide not only certificates proving the quantities delivered to the recycle center, but also the quantities recycled.
Sorry, just other 1 minute, 2 minutes.
Okay, allora, yes, very briefly, based on these clear requirements, the construction was provided with separate waste collection tippers, you can see in this picture. And there is, during the construction site, in this picture, you can see the amount of the quantity or recovered waste material, that is about 98% that materials recovered. And then I go straight to the conclusion. And a center for storage materials for use in the field of paper recovery and metal collection were activated locally, and another center for the recovery of inert material from demolition locally. And in conclusion, according to our study, I would like to sum my main points. Implementing circular procurement means going beyond the lowest price. At a work stage, the contracting authorities can evaluate the quality and the circularity aspects of the tenders using the predetermined work criteria. Planning the green procurement for work is essential for delivering environmental and social value, retaining economic benefits. And finally, I would like to highlight that the GPP can be seen as an important enabler for the development of a holistic approach for supply chain collaboration in closing and slowing resource loops in the construction sector. That's for my side, and thank you for your attention. And now I am happy to answer any question you might have.
Thank you, Margherita. And okay, the question will be postponed at the end of all the talks.
Okay, then we switch to Michiel for his presentation. Michiel, stage is yours. I will give you a signal when 1 minute is left.
Yes, thank you, and sorry for the inconvenience. Thank you, Margherita, for jumping in here. I actually mixed up the two presentations I'm giving today. It's actually the same picture, but it's a different story. The other story is more about the concrete, and this is about the complete project. Very interesting, Margherita, as well. What you showed is that the potential of circularity is 95% expressed in mass, of course. We did some additional calculations as well in the field of the environmental impacts to see what is possible if you start harvesting from a project. Go to the next slide. So the background, I think, Dario, you already sketched it very nicely. We are facing serious challenges towards a highly decarbonized built environment. So we need to focus on zero energy, but moreover, including the material aspect of becoming 50% circular by 2030 and 100% circular by 2050. Moreover, in our region of Parkstad, we have a significant demolition assignment. So about 10,000 dwellings will be demolished and 150,000 square meters of utility and retail. And we see a high level of concrete as well in that in those projects. And so at this moment, the recycling rate and the circularity rate is really very low. We see only about 3% of demolished materials going back actually to the building construction. And people say that we already recycle about 95%. 85% of that mass is going into civil works, and that is actually not recycling, it's downcycling. We use materials on a lower level, and this is very typical. What we do with demolished materials. So they end up in these garbage bins and then are downcycled or completely destroyed. So we need to change that. And how can we change that? Well, we use this 9 Artan R model. The numbers fluctuate a little bit, but the most important thing is to start rethinking what do we really need, and then redesigning, and then from the user phase, think about reusing, repairing, and recycling. And that is what we applied in this project Super Local. We had 4 of these buildings. Probably a lot of you saw some presentations about it yesterday as well. These buildings would be traditionally demolished, but we said, let's apply this model and see, can we harvest materials to build new building objects? So we did it in 4 steps or 5 steps. We started with an experiment, the Expo building. After that, we scaled it up to 3 pilot dwellings, and then we scaled it up to 15 single dwellings. We started first with an inventory of these apartment buildings, so we know exactly what is in it. All these components, we made QR codes for them. So we know we put about 10,000 QR codes in the project, and we did an environmental impact calculation, which you can see very briefly here. So we know exactly what mass is in the building and what are the environmental impacts. And in the graphs below, you see that the concrete is really the main element. So that's a very good point to focus on. From that point, we developed these three dwellings. So in the back, you see the apartment building. In the front, the three dwellings. They're now completely finished, and we reused and recycled a lot of concrete. And the maximum we did is we harvested these complete apartments, hoisted them out, put them on new foundation, which you can see here, and then we finalized the dwellings, and they look now like this with different cladding materials. We did a comparison between these three dwellings and new dwellings. And what you can see here, especially in the graphs below, in embodied energy and embodied CO2, we can really save about between 60 and 70% of embodied energy and embodied CO2. So applying this method really results in a lot of environmental impact gains. As well, we looked at upscaling, and what we noticed was that we can really save a lot of energy and embodied CO2. You can see it in the top right, the CO2 baseline versus superlocal. So the baseline is traditional demolition and new construction, and superlocal is harvesting to a max of 50 apartments from such a block. However, the lowest graph on your right hand shows the costs of the baseline versus superlocal, and there we can see that this solution is still not feasible in the current economic model. And later on, another presentation will go deeper in this aspect. So concluding, and I hope I'm still within time. So we did this inventory of what is exactly in this apartment block. So we see a lot of embodied energy, a lot of embodied CO2, and in our current linear processes, they're completely wasted. They're downcycled and they're not used anymore on this high level of quality. So if we look at what's actually possible, we can harvest 50 apartment blocks from this a big apartment block to construct 50 new dwellings. And so by doing so, embodied energy and embodied CO2 savings can reach over 65%. What we see as well is that now that we're analyzing the dwellings, they're really based on a circular, single cycle circularity. So the houses are built with reused materials, but not in such a way that it can be reused and reused over and over. And that's actually ongoing research in our group. How can we improve this so that they continuously stay in these loops? And so in future, we really have to design buildings with this end of life possibilities, for example, based on design for disassembly indicators. Thank you for your attention.
Thank you. And okay, Joop. Okay, I will present the third speaker. The third talk is about circularity in selected European Union countries, the case of construction and demolition industry. And the presenting author is Dr. Norman Dytianquin.
Yep.
Please.
Correct.
Sorry.
Okay, let me share my screen. I don't know if you can see the screen.
Not yet.
Not yet? Okay.
Yes, there it is.
Okay. So,
no, it's gone.
Oh. How do you do this? So let me see. Window and share. Okay.
Yep.
Can you see anything? Okay. So yesterday so this is a collaboration between two research centers One, we have the international, we have a new research center in South Maastricht, and this is called the Sustainability International Business, where we liaise with SMEs on sustainability issues. But we also have a collaboration with SURD, which is the Sustainable Urban Redesign of Haarlem, South Haarlem, and these are the authors. So the three of us belong to Maastricht, and Michiel, who just spoke, and John van Oorschot come from the Academy Built Environment. So yesterday there was a question, why is this called Crossing Boundaries? So it's crossing boundaries across disciplines. But here we have decided to cross boundaries literally by looking at and comparing different EU countries on their experiences in trying to balance sustainability dimensions. And we call this the triptych because it's about environment, economic, and social sustainability, people, planet, and profit. So we compared projects, and our theoretical construct here is that we have determinants or antecedents to determine project success in sustainability. And these are the stages of circularity, which we call the circularity ladder, the architectural design principles that are being used, where in the life cycle of construction are you in, and the availability of country strategies in circularity, which we learned yesterday was a very important determinant. So our expectation here is that project success in balancing sustainability dimensions depends on these four determinants, and I drew a mind map of how this looks like. So here you have the triptych, environment, economic, and social, and these are the determinants. So I have skipped some of the slides because these have to be explained later, but in the Q&A, if you have questions on building principles, for instance, the 9 R's of circularity stages in the different life cycle of the construction industry,
Norman,
then you can
Norman,
yeah.
Sorry
Yes.
to interrupt, but we still see the first slide.
Oh.
The slides are not running. Yes.
Okay.
Sorry.
I thought it was working. So let me, how do we, I think it's better to just share the, to just look at the, what they call this, to show this, okay?
Yep. But
you
try
see
to.
it?
Yeah. Now we do see slide number 4, I guess. Yes.
Okay. So essentially in slide number 4, I am showing the mind map of what we're trying to do. So these are the determinants. You have the policy, you have the building, architectural building principles, you have the life cycle of construction, and you have the 9 R's, the circularity stage. And now I move to the methodology. So we actually looked at, these are the criteria in choosing the countries, the availability of data in terms of project description. We need the interim or final assessment reports of the projects, the existence of project websites, reviews on architectural digest and journals of these different projects. And then we also made sure that the different projects represented diverse elements of the determinants. So I have a slide in this later. We can look at this. So not all of them are in the same life cycle of construction. Not all of them are using building in layers in architectural design. So they have different stages. And then we look at the availability of country strategies. And finally, the countries that were selected belong to the top 10 waste generators inside the EU. And these are the countries: the Netherlands, which is number 4, Belgium is number 6, Denmark, Germany is number 5, and then we have France as number 7, and Denmark is number 9. So the projects that we have chosen are the superlocal project, which Michiel just explained earlier, and this involves demolition of apartment blocks and creating 100 new homes. And they use reconstruction techniques, which is actually reusing the entire hull or shell of a studio and supplanting it again on land and reusing it. They also used trying to remanufacture stackable bricks that can be dismounted later on. And then they also try to upcycle concrete rubble and then try to manufacture it into new concrete to be used. The other project, which is in Belgium, is the Circular Retrofit Lab, which involves student housing inside the Vrije University in Brussels. And this also involves the use of prefab modules that can be rearranged in spatial reconfigurations, which they call reversible solutions. And then we have in Germany, the Open Air Library, which is a community endeavor that actually was started by residents to reclaim abandoned industrial land in East Germany. And they created the library using beer crates as building materials, and they donated books. So everything is public. So they all donated money to do this. And they also were responsible for designing the library, as you could see from the small picture there. The next project is in France, which is the Réhafutur Engineers House. This belongs to a typical mining house in northern France, which is UNESCO protected historical site. It involves refurbishing the whole building, which is converted into office spaces using eco materials as insulation. And then they also try to protect the cultural heritage so that you cannot touch the facade of the building. You can only work on the interior. And the last project is in Denmark, which we call Upcycle Studios. There are 20 terraced houses which are using recycled or remanufactured materials. So based on this, this is too fast now. So based on this, we have the results, and the best project that balances environment, economic, and social impacts is the Réhafutur House of France. So it's called scored. So we rank them from 1 to 5, with 1 being the best. And of course, we average them, and we saw it ranked the best. So it balanced the 3 dimensions. And using the mind map, we see that all these dimensions, we see that they all targeted the middle, which is the balance of environment, social, and economic. If we look at the German project, they focus more on the social. So they are on this side of the diagram. And then finally, we have the key takeaways from this research. CDI projects should actually strive for the balance of sustainability dimensions, and not just on environment or social or the economic, but actually the balance of the 3. And then we need the presence of national strategy in providing direction and impetus for circularity, so that the mindset and their mentality takes root. In fact, one of the projects in Germany, they didn't have any strategy. So they even hired Netherlands to do a consultancy work to create a regional strategy in Bavaria. And then the project can address more sustainability dimensions if, and these are the conditions, the higher the circularity stage, such as remanufacturing, refitting, refurbishing, retaining, then the more you can address social and economic impacts. And then the next condition is that the design principles, building in layers, building for adaptability, building for disassembly. Here you can put in a lot of economic and social dimensions on sustainability. And finally, the design and use phases of construction life cycle. This is also where you can put a lot of economic and social, and not just the environment. So that ends this presentation. Thank you. I hope I was on time.
Yes, thank you, Norman, for your clear presentation. I think, Dario, you will introduce speaker number 4, and then finally I will introduce speaker number 5.
Okay, the next talk is about using circular thinking to design a new system logic. And the presenting author is Professor Peter von Assche. Sorry for misspelling.
There we go. Good morning. Thank you for the introduction. I'm happy to be here. Are you there? Yes.
Yes.
Perfect. Yes. So my name is Peter van Assche, and I am, well, actually not professor, lector. I think I'm a colleague of Joop van Duren, lector at the Amsterdam University of Architecture, Amsterdamse Hogeschool van de Kunsten. And this is something I do one day a week. Mainly, I am busy being an architect in my architecture studio, Bureau Sla, which is based in Amsterdam. I hear a funny echo. Is this also happening with you? Is there something I can do? No, still there. Dario, maybe you can switch off.
We can only ask all participants to mute their mics unless the speaker. So please, if you would mute your mics. Continue, please, Peter.
Yes, of course. This is better already. Thank you so much. So I will talk a little bit about circularity, but I thought it would be very interesting and very maybe inspirational to talk a bit more about two examples that we did as hands-on research, practical research and practical designs. I see that I have been a bit optimistic. I have 49 slides, so this means 5 slides per minute. And this is going to be fine. It means 6 seconds per slide, so I have to speed up. But it will be fine. You will see the end of the story, I am sure. First, I would like to start with models of doom. That is actually what was named in the newspapers, the research that was done by these 5 people. They were later called the Club of Rome, but these 5 people in MIT, and you should remember these names because they really changed history. These 5 people had this insane idea. Let's make a computer model of the world. Let's make a computer model of how the world acts and the human behavior in it. And it was called World 3, which is a very funny name for a computer model, also very boring. And this was the computer program. And what they found, and I will not go into it, is that they put in all the data of pollution, of economy, of population, of resources, and they had this from the year 1900, and then predicted according to 11 scenarios what would happen if the mankind would move this direction, mankind would move that direction. They had one stupid scenario, and the stupid scenario was called the normal run, the standard run, the business as usual scenario, and that would mean that mankind, so us, would not change our behavior. And then in 2014, and of course you can see this standard run scenario would inevitably lead to a collapse scenario in 2070. So they wrote it in 1970, collapse in 2070, so 100 years to go, 100 years to save the world. And then an Australian professor found in 2014, he thought, okay, let's see what happened after 50 years. And he found out that actually we are doing the standard run scenario. So down we go. And then, of course, you could see this as a very harmful and bad message. Some people will say the Earth will die, but of course this is not the case. The Earth will not die. We have had these levels of carbon dioxide actually a lot in the past, high levels of carbon dioxide, high levels of temperature. The Earth will not worry. The only thing that will happen is that we will destroy mankind, but Earth wouldn't mind so much. This has led to the Anthropocene. I don't have to explain you so much about this because you're all experts, I imagine, but this Anthropocene means that mankind, human people, have a significant or the most significant influence on the behavior of the Earth. And instead of going into this, I would love to show you some images that are made by Edward Burkinski, and I asked him for permission to use these images in presentations, and he was so kind to do so. And it only shows what people do to this planet. And actually, these images are so beautiful that you make them love human activity, and it sort of almost implies a weird fascination with beautiful images of the destruction of our Earth, or of mankind, that said. And you should see his movie. It's called Anthropocene. This movie, I can really advise you to see this movie, because it's a beautiful way of showing what we do to this planet, aesthetics and destruction. So I will show you two examples that we did with friends and colleagues and researchers and so on, 2 heroic attempts to build from scratch, because we have to invent a new system logic. We have to invent new ways of dealing with stuff. And the first project we did was we started recycling plastics, household plastics. And by making these images, what you see here is waste, nothing else. What you see here is waste, and by photographing them in this way, it almost reveals already some kind of a beauty. You could imagine when you see these images that it's not waste, but it might be raw material. Of course, we didn't know how to do it, but it might work. And this is not the ordinary way that we show waste. This is the ordinary way that we see and produce waste. It's going to be piled up and then mostly recycled, as they say, but in most of the times recycling means burning, putting them into fire. And it's called calorical recycle, but this is of course a bit of a joke. Because it's not real recycling, it's just burning them. And then, so we had this fantastic idea. We said, okay, we are going to use all this plastics because it's good material and turn them into a building material, into a sustainable building material. And then we went to all the factories, this is a few years ago, to all the factories and saying, we have this great idea, we're going to use your machines to make this building material. And then everybody told us, your waste, your stuff, your garbage is not going to be in my machine. So we had to make our own machines, and that's what we did. We made these machines that are not very unique by themselves. It's collecting, sorting, washing, sorting, shredding, and molding. Each of this machine represents an industry, but these industries never talk to each other. So the only thing we did was we connected industries on a very small scale. And this was the first project that we did. What you see here is 100% waste, plastic waste that is also in your garbage bin. And we didn't change anything except for this sequence of procedures. And we, of course, we loved it. We couldn't believe it was so beautiful. So we were able to make 4 of these little pavilions for the university in Amsterdam that are sort of reading booths, and also these plastic construction elements you see they are plastic waste planks, also made out of plastic, by a Belgian company. So all you see here comes out of the garbage bin, except for the lamps, the steel, and the girl. It's all out of the garbage. So this was a huge success, and we started to developing more in this way. And this was the second version of this plastic waste tile, meant to be obtainable, real serious building product in large quantities. And then we were able to make details, different kinds, and make specifications, and people started using it. So people started using our product as a serious building material that would last 50 years. And this building material now has all the certifications. It's fireproof. It is all construction proof, so you can have all the papers as well, which is interesting and also needed in a circular economy. It's not about making interesting, nice objects. No, this is a serious business, and it should have large quantities and a bigger turnover to make an impact. It's not about making nice things. It is about making a lot of nice things. So now we are able to have this. This plastic factory, and we are able to make 130,000 kilograms of waste, turn it into a serious cladding material, and have 4 million of quotes already this spring. So I will skip a bit of my slides because I see I only have 3 minutes more, and I almost managed, but not quite so much. The point I want to make is there is no such thing as a linear economy. The Earth always works circular, and building also did. I will go to the last project. We use this model of Stuart Trent, and of course this is not an old model. This is a young model. This is not a young model. They already did this. This is a picture of the 1950s. And what we did, we made a pavilion out of materials, and you see the tile here as ready. That was completely borrowed. So we borrowed all the materials for 9 days from manufacturers, from people, from everybody. And I will not go into it. I'm sorry, 10 minutes fly. But after 9 days, we gave all the materials unharmed back to all the people that borrowed us these materials. And here you see the image of this pavilion after deconstruction. It's the same pile of materials that was used before the construction. Exactly. No screws, no glue, no holes. And sorry, what the statement I want to make, and then I will finish, is that if you think about circular designing and circular thinking, it is not just about materials, and it's not even just about construction, but it's also, you have to think about new economic models. You have to think about new processes. I will not go into it, but a circular approach demands new processes. And then you will find new typologies, as we saw in the examples shown before of Michiel Ritzen and Norman. And you will find a new architectural expression in the way we make our buildings. So thank you very much. And I see some questions, but we will save them for after the last presentation, I think.
Yes, we will. Thank you, Peter. A very clear presentation. So this brings us to the point that I can introduce the last speaker of this parallel session, and that will be Albin Rohith. He's a junior researcher working at Zuid University, and Albin will get into the more economical perspective of circularity. So he will be talking about business models. The stage is yours, Albin, and I will give you a signal when 1 minute is left, okay? You have to unmute, Albin. You have to unmute, Albin.
Oh, can you all hear me?
Yes, now we can.
Okay, perfect. I was having some issues with the button there. It wasn't working, but good morning, everyone. For those of you who know me, you know me. And for those of you who don't, my name is Albin, and I work with Michiel Ritzen and Mr. John from Zuid. And for the last 1.5 years, I've been working on the concept of circular business model experimentation for the construction sector. And we worked on 2 projects, Drive Zero and Super Local. And this was what my summary was for the paper that I published in this conference, which I'm very happy to. And for today's presentation, instead of talking about both the case studies, I would like to focus specifically on one due to time constraints. And yeah, to give you an description of what we will be talking about today, I give you a brief description of the case, and then I talk about the taxonomy of circular business models we developed during this research project. Then I give you a methodology of the case study assessment, the data, how we assess them, and finally with the research findings, the proposal for the companies and the key takeaways from this project. Professor Joop, I'm having issues with zooming in on my PowerPoint here.
Yeah, perhaps try to share again. Oh, there it goes.
Yeah. Oh, okay. Now it's much clearer. Yeah. So moving back to here. Here, what we mainly did is we wanted to explore circular business modeling and how it works for construction companies. Here we focus on 2 big construction companies. And what we did here is we initially assessed their current models. So these are companies who are in a transitional phase from a linear to a circular economy. And the different companies, they have different standpoints on what level of circularity they have. So how we managed to tackle the issue here and solve the objective is we wanted to uncover what exactly is the standing of the company, what level of circularity do they have at the moment. And once we knew what level of circularity they have, then we could propose strategies and areas where they could improve or enhance their strategies. And this will help them achieve full circularity, which is the aim of this project. And to give you a brief description of the company here, we interviewed 2 companies. Company A is a medium-sized enterprise. It's in a transitional phase to a circular economy. This company offers wood-based prefabricated facade solutions. So it's completely made automated in a factory, and then it's transported to the construction site and installed, or sometimes it's done by the construction company. Company B, it's also a startup company. It's a very innovative company with regards to their technology. What they did is they developed a fully integrated climate energy module. This module was developed in the factory, produced there, and it was transported to the construction site and installed. Here is a description of the assessment methodology we developed. So what we did here is we developed an assessment tool. It was a checklist questionnaire, and this survey questionnaire, again, as I mentioned, was developed to assess the degree of adoption of circular strategies by the 2 companies. So as you can see here in the picture, it's a little cutout of what the questionnaire really looked like. And this questionnaire was split into 2 sections. Section 1 was assessing the organizational value business model dimension of the company. And the second one was assessing the value proposition business model dimension of the company. And here we had 4 options for the companies: poor, neutral, good, or excellent. And this was for them to answer. And based on their answers, we allocated scores for each of these selections. So poor would be 0, neutral 1, and as follows, as you can see on the slides. And these scores, the total scores, were then used to find out how much % of organizational value of circular strategies are adopted by them, if it's high, if it's low, which I talk about in the next slide here. So here was the answers when we got from the companies. We tallied the scores for each individual company for each of the 2 business model dimensions. And as you can see here, there's company A, for example, which received 47% value proposition. And sorry, I really cannot see with the zoom here. Yeah, and company A received 47% for value proposition and 62% for organizational value. So what this basically means here is that we tallied all the scores for all the questions that were there, and we saw what standing there was. And any score above 50% was considered high, and a score below 50% was considered low. And once again, these were hypothetical approximate estimations, but we just wanted to make it really simple so we could focus on the main part, which was providing them with strategies. So we classified the companies across 4 levels of circularity, which is enlisted in the figure below. There's the first one, which is high degree of circularity, which is when a company has both high value proposition and high organizational value. Then you have upstream circularity, where it's low value proposition, high organizational value, and the rest, as you can see in the figures. From our findings, it showed that both company A.
You stopped sharing screen?
No, that happened automatically, but I will reshare it.
Yes, there you are.
Yes. Yeah. So as you can see here, from our findings, we found out that both company A and company B fall under the category of upstream circularity. And this was because of the scores that we tallied in the previous section. Now to give you a findings of the company, Company A, we found out that this company incorporates circular business model strategies in their product design phase, research of old materials, manufacturing and innovation, but they did not transmit these values of circular strategies downstream. So what this means is that their mission to a circular transition does not emerge clearly in their marketing strategies or campaigns and with their customer relationships. And this is because of two main outcomes. Company A does not provide incentives for its customers for product take-back programs. In addition to that, they currently are not looking forward to formulating any product take-back programs. Next to that, they miss the crucial aspect of retaining ownership of the product, which if they do would benefit them in a lot of ways, which we discuss in the next slide. For Company B, it was classified again as upstream circular, as mentioned before. This company incorporates circular strategies in their design and manufacturing of products, and then they ensure key aspects like that their products are easy to repair, easy to maintain, and that the products have extended value throughout their life cycle. Despite all this, the company is still not fully circular, and this is because of the following reasons. First, the company does not have any aims towards utilizing refurbished or recycled materials. It does not offer any product take-back programs for its clients. It gives minimal considerations or none whatsoever to socioeconomic aspects in its cost-benefit analysis. Another key issue that it faces is the issue of organizational silos within its organization. And lastly, it also does not focus on retaining ownership of products during use phase, which opens up multiple possibilities for in the future for the company. So based on these findings, the strategies we proposed for both the companies is what I will be discussing now, and we will go from Company A and then to Company B.
You've got 1 minute more, Albin.
Yeah. For the first company, we found out that Company A plays a positive role in designing and manufacturing products that are easy to maintain, repair, and possess high value. However, it does not capitalize on this outcome because the company does not provide its clients with product take-back programs or any incentives. Whereas if this company offered its clients with product take-back programs, the company can, let's say, retrieve its product upon end of life. And because the company designs products which are meant for long life, the products will have a high residual value upon end of life. And with this, the company can result in multiple revenue streams because they could either refurbish the retained products and sell them as secondhand products, or they can sell them to material suppliers for recycling. So as you can see here, there's a strategy which they incorporated, which is circular, but it's not reaping maximum benefits because it was not followed through by implementing other strategies which could have boosted that. And this is the case you see with another strategy of theirs. It's incorporating product leasing as part of their business strategy. If this company broadens its horizons and opportunities for product leasing business models, combining this strategy with strategy one will enable the company, again, to benefit from two standpoints. One is from an economic perspective. The company will have extended client-supplier relationships instead of a one-time trade-off. And from an environmental standpoint, taking back products at end of life and refurbishing them will enhance the company's contribution to the environmental standpoint by reducing material usage and further enhance the company's green image, which will further attract more clients down the road.
Albin, we've only got time for one final conclusion.
Okay, then I will...
What would be your final conclusion over here?
Yeah, the key takeaways from this is that what we noticed with both the companies is they are aiming to become circular, but they are only picking certain strategies, which adds a little value. Whereas to reach full circularity, a whole overview has to be made on how each decision affects the other and how one decision can further be boosted by adding another strategy in place. And this can only be achieved by having a whole integrated approach to the whole process. This is by having a combined discussion with all the stakeholders, with the supply network, with the demand network. And when this is done, then the companies know what all strategies work together and give the added value in reaching full circularity.
Okay, thank you, Albin. Thank you for this interesting presentation. We run a little bit out of time in this parallel session. We've got about 10 minutes for Q&A, but as I saw, some questions were being put in the chat and they are being answered for partially. So let's take the same sequence as the presentations have run, and then a question for Margherita. I personally think the role of procurement in becoming circular is a very interesting one, and my question is, applying a GPP like you explained to us, what do you personally think? Should we as clients prescribe what we want, or should we challenge the market?
Thinking at the present situation, I suggest to make it mandatory in the call for tender in public building, because if you wait for something that will happen spontaneously, I think it's too late. It's an urgent situation now, so we can wait that the market or the construction firms or the technicians will be prepared to do this. So I think that public and municipality have to join the effort with the academic experimentation or study, and they can link together what is they can trigger in the call for tender, because you can imagine if our public buildings were built as Peter showed in his presentation, or as well as my presentation, you really have a massive change in the market and a very high quality in the building. Also, not only about the simple quantity or recycle materials, but it's a completely change of the mindset, and so a circular thinking approach. But you can push in the call for tender for public building, and the industry has followed the public authority.
Okay, thank you. Some questions in the chat were about evidence, in a way that all the waste fragments are being recycled. You've got certificates. Is this really evidence-based?
Yes, because usually the percentage about the recycling quantity is already related to the materials that are taken into the recycle center, but you doesn't know effectively if this quantity that are taken in the recycle center are actually used in the recycle way. Yeah. So in the call for tender, I specifically ask to provide the certificate of the quantity recycled. Okay, the quantity that is in the use in the market.
Yeah. Okay, very well. Thank you. Dario, perhaps you do have a question for Michiel, a second presenter in this session.
Yes. First of all, just a question for myself, and then there were some questions from the chat. Okay, the project that you explained in the methodology are amazing, both. But I was thinking, such a pilot project, do you think it's possible to apply the same, not the methodology, but the reusing of the wall building part as well on the city center, historical city center, or where there is like some lack of space? And so I can imagine how the transport of such big module can impact on the final result, or also on the environmental impact of reusing. the building component.
Yes, thank you for your compliment and your question. This is one of the questions we of course started with. What's the optimal solution? So what's the optimal scale of reusing building components? And yeah, your questions, I think, are in that sense spot on. These very big apartment blocks it's unfeasible to upscale this solution due to a number of factors. For instance, if you transport such a complete apartment unit, it's really actually impossible to do it over longer distances. Moreover, what we've seen in our analysis is that selecting this very big component leads to such a energy investment due to the cranes and all the additional elements that's not the optimal solution. The optimal solution is more on the level of smaller concrete slabs. And so, for instance, like 1.2 meters by 2.4 meters, which can be cut out more easily and hoisted out more easily, transported more easily. But the big challenge is there that our current apartment blocks are not suitable to do so. So there's still a big challenge there.
And there were another question from the chat before, like, would you please tell us about the expenses for dwellings? Is it compatible with using new material?
No, what we of course looked at, and I think Albin actually can answer this question better than I can. Albin.
Yeah.
Albin or Norman?
Oh, I thought Norman. Okay. So would you like me to answer this?
Yes, please.
Okay.
What are the costs and benefits?
Okay, so from what we saw from the analysis is that for technique 1, it was almost impossible from a financial assessment, also from an economic environmental standpoint. For the technique of bricks, we found out that the costs are higher than using traditional construction. However, if it's implemented in a large scale, that is, if the economics of scale is increased and if the machinery is further developed, then we believe that it's really feasible to use this technique. And the most interesting thing is that for the last technique, where circular concrete is produced and poured on foundation, from our cost analysis aspect, we think that it is actually cheaper to carry out circular construction using circular concrete than using new concrete.
It's an impressive and interesting result.
Yeah.
Okay. Then we go to Norman. I saw one question in the chat for Norman, but I think he already answered that one. So my question for Norman would be: you compared these EU countries on their performance, the circularity performance, so to speak. What was the most remarkable outcome, in your opinion? You have to unmute, Norman. We can't hear you. You have to unmute your mic.
Doesn't show. Okay. So now can you hear me?
Yeah, now we can hear you.
Okay. So the most, what was the question again? The most
remarkable outcome of the comparing these EU countries.
The most well, we need policy. So some of the countries, they have detailed policy, even at the sectoral level. So countries such as the Netherlands and France, they are so detailed in their policies about circularity in agriculture, in construction, whereas all the other countries, they were only at the city level. Brussels, for instance, they only have it at the city level and not at the countrywide level. Germany doesn't have any. So, and you see, that's why in Germany, the project was pioneered by the residents. They took over, and that's why they scored very high on the social dimension, because everything was done by even the contribution of the materials, the beer crates, the contribution of the books, they all came from the public. They also contributed money. They donated money instead of relying on subsidies from the government.
Aligned European policies is what we need over here.
Yes,
okay.
Which also came out from yesterday's plenary.
Yeah. Okay, and then I see it's 2 minutes to 10:30. So the last question, perhaps for Peter van Assche. You described a very inspiring story about designing circular, and in that story, what we saw very clearly is that you need the whole supply chain, and at the same time, this is a hard one because in the whole supply chain, we need this paradigm shift. What advice can you give us at the end of this session to contribute to this, to achieving this paradigm shift?
Yes, thank you. And this is a very important question, I think. So what we see here is that we started doing this little experiment. It's like you have a piece of wool and there's one or cloth, and that there's one thread sort of wrong, and you take it out and you discover that if you keep on pulling that the whole thing changes. So by doing this one little experiment, we found out that you don't even have to, or it's not just even the supply chain, but it's even the mode of working, it's even the way of thinking, it's even the way you deal with money. So on the one hand, you have these experiments which we love to do that show, yes, it can be done, but it means a systematic change. And then on the other hand, you have, as Norman and Margherita point out so well, we need policy. So we need policy on a bigger scale to make these experiments scale up to a worldwide, for me, paradigm shift.
Yes.
So both you need, yes, it can be done, and how do we scale up? And that's politics. So we should not be naive there. We need policies.
Yeah, so perhaps the final conclusion of this session could be we need aligned policies on a European scale, and we need visionaries with courage that act and simply do.
Yeah, and then they have to meet.
Yeah, and then share and meet, exactly, yes. Okay, so it's 10:30 by now. I would like my co-chair, our Italian guest, Dario, to give the last words on this session and to do the closure.
So first of all, thank you to all the presenter, and we listen a lot of interesting suggestion and pilot project. So just to wrap up what we listened in the morning, I think that they emerged several points. The first one is not the circularity, the circular economy is not only focused on materials. I mean, the material, of course, are the important, the basic, the elementary unit of recycling or reusing, but we need to assess the use of material in different way, from environmental impacts as the embodied carbon or other indicator. Second, from the talk of Margherita, we listened the fundamental role of the public administration in reusing, recycling material, and the role of the green public procurement in the renovation process of the building. Third, from the talk of Peter, we listen. That we need not only way to assess and policies, but as well we need to think in a more systemic way, and also in a more creative way as well. And so we have not to focus again only on technical aspect, but we need policy on one side and innovative solution on the other to recycle or upcycle the material. And I think finally with the discussion of Albin, we see that also the firms has a role, of course, in this process that is more related on changing their business model, including engaging the stakeholder in within the supply chain, from the supplier up to the final consumer, and so it's necessary to change the strategy from like product take-back program or reverse supplying or leasing for company in order to induce also the consumer to reuse or recycle the materials. And so we have I think a huge and long path to do, but we listen very insightful and inspiring contributions, so we can do it, I think. In the next, we can achieve it in the next future. Thank you to all, to the speaker, and to all the listener and the audience. And I think there is a 30-minute breaks before the next session. So enjoy the break.
Okay.
Thank you.
Thank you. Bye.